Hello, 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 chat. Hello, 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 chat. Don't know why, but the stream is, I think, running in a little bit late, like in a delay, right? Like there is a delay of maybe 3 seconds here, and also in the OBS studio. Don't know why. Maybe there's some settings have been changed. Why? Like I'm explaining the things, man. I'm not supposed to do this. Okay, the stream is getting stuck. Hello, hello. Hello, everyone. This is the day 33 of my C++ DSA journey. Um, Today we will revisit some problems, and after that we will try some new problems. Um, yeah, just wait. Let me paste the link in the Discord. If anyone will be online, he or she can join. Hello, hello. So the first revisit that we will do is the problem name is peak index in a mountain array. Today I will try to not see like not see the mobile phone and not focus on this comments. I will try to also improve my skill of like seeing comments also and in between switching it to the screen, right? To the main screen in which we are solving problems or explaining things. And yeah, today I saw that ranking has improved a little bit. I think yesterday it was around 26 lakh to 40,000 plus approx. So first revisit of this problem. So I think we should revisit this. Then after that, we will try some new problems today. And according to the roadmap, we have to like do two new problems today. Like today is not that decided, but I have choose like I have some problems in my list in which I have choose some from them. Let's see how it will goes. Maybe today, if time will allow, we will try another problem like going against the roadmap, right? So what is given in the problem? We have given an integer mountain array. Okay, array of length n. Okay, of length n, where the values increase to a peak element and then decrease means mm, till the peak element comes, the value comes in increasing manner. and after the peak element, the value comes in a decreasing manner. Okay, so we have to return the index of where the peak element is, and our task is to solve it in log and time complexity, and because of that we will use binary search in that. Okay, like here is an example given. Here 0 and 0 are just, let me show you the here. Like I have solved explained it yesterday. Like 0 is this index, suppose 0 is this here and 1 is here. So we found a mountain, peak mountain index will be this. Okay, like the first index, that value is 1. And we will return only the first index, not the value of it. Mm, and there is also another condition that peak index can't be present on the very first or the very last, because when it will be on very first or very last, suppose, then it will be in a it will not form a mountain type structure, right? That's why. Like suppose it was on the first and after that it came, then it will be like a line, right? Like a straight line going down, and it will not be behave like a mountain, right? And suppose if it was on the very last, like 1 was here and 0 was here, then also in that case it will just be a line, okay? That's why. So maybe the problem can be a little bit confusing starting, but when you start it and is equals to hmm, yeah, first we initialize two variables in binary search. After that, we find the mid of the values. Okay, and yeah, here start will start from the first index, right? Instead of the zeroth, like very first, because we already know that peak will not exist at the very first or at the very last index. Okay, that's why we will check from the second index. Oh, sorry, second value to the second last value. Okay. And after that, we will use a while loop where we will use a while loop where start is less than or equals to end. Okay, just wait, man. There's again a disturbance came. Okay, fine. In between, some disturbance keep coming, so because of that, I get a little bit. Okay, why start is less than end? Why I've chosen that? Maybe because I will tell you. Because maybe at some point start and end can be maybe at the same point, right? Like I will show you in this case. Like in the starting, in the very starting, it will be on the very first, like this index, start and end will be present on the same index. So after this, we calculate the mid value in binary search. We calculate the mid value by adding start plus end minus start. Okay, we have to keep this in a bracket, and it will be divided by 2. Okay, this is the optimized formula to calculate the mid value. Yeah. And after that, we have to check for a condition if nums, yeah, if nums is nums mid value, if it's maybe it will be equals to no, if nums mid value, okay, we have to write like this: if nums mid plus 1, sorry, mid minus 1 value is less than nums mid, okay, and nums mid is more than, sorry, here will be nums mid and okay, because we have to check for both conditions, and nums mid value is more than nums mid plus 1, because peak index will be bigger than the previous index value of it and also the next index value of it. Okay, that's what we are checking. If it's more than mid minus 1 and mid plus 1, then in that case we will just simply, yeah, we will just simply return mid index in that case. Okay, maybe this will be the case. Else if maybe there will be a case where what, where maybe nums mid minus 1, maybe nums mid minus 1 is more than nums mid, right? Then in that case we will simply reduce the search space, and now search space we will check for it in the left side of the array. So for that we will do end is equals to mid minus 1. Okay, and suppose maybe mid minus 1 is less than mid, but maybe mid plus 1 is more than mid. Okay, then in that case, then like else if nums mid plus 1 is more than mid, sorry, nums mid, right? Nums mid, then in that case, we will check for it in the right side of the array, means we will start with mid plus 1, right? And suppose we not found the value even after traversing the array, like in between the values, then in the end we can return minus 1, right? Yeah, we can return minus 1 in that case. So here it will be return minus 1, right? If it will be like there will be no peak index present in the array. Okay, here's the semicolon missing. Let's just see through the code. Maybe there is something missing. Return this. Fine. Okay. Uh, 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 Come on, man. Come on. Okay, it's accepted. So you can see in this case, then we calculate the mid, and will be start will be on the first index, means this, and end will be the on the second last index, means second last index is also this. So when we will calculate the mid of that, then it will be 1 plus 1 divided by 2. That will be equals to 1, right? And 1 is what? 1 is the this index, right? So when we will check for it, it will return 1 in the end as the peak value, because it is the peak value. We can clearly say it because it's bigger than the previous value and also the next value. And why we initialize this with the yeah, second value and second last value. Why we did that? Because maybe mid can be at any place. Okay, maybe mid can be at this place or this place. Then in that case we will be trying to access that value which is not present in the array, because when we will compare, like suppose mid is there, when we compare it with mid minus 1, there is no mid minus 1 present in the array, and it will give segmentation fault, right? It will be a segmentation fault means we are trying to access that area of the array which not exists, right? And in this case, suppose end is like it is on the end, like mid is on the end, then we will compare it with mid plus 1, then there is no mid plus 1 value that we can compare for. And again, we will get segmentation fault, like we are trying to access that value that is not present in the array, that not exist in the array, right? And these are just conditions, some conditions. We calculate the mid, then after that we check if mid is more than mid minus 1 or mid plus 1. If this is true, then we will return mid, means because it will be the peak index, right? And else if it's less than, if it's less than mid minus 1, then mid minus 1 will be the peak index, right? Like it can be a possible peak index, then we will initialize the end with mid plus mid minus 1 and again again calculate the mid every time. At every iteration the mid is being calculated and the search space is also getting reduced. Okay. And we also suppose if mid minus 1 is not more than mid, then maybe mid plus 1 will be more than mid. Then in that case, we will just check it in the right side of the array by starting start is equals to mid plus 1. Okay. And if we not found the value, maybe even after checking in the array, like we not found the peak index in a mountain array, then we will return minus 1 as we not found the value. And time complexity of the code of this will be equals to what? This will be equals to big of log and write. Let's check it. Log and write. So now I will take a 5 minutes of break because there also the evening lunch has come and there are some bread and yeah, bread and kada. Tea, you can say black tea. So first problem. Where I visited name was peak index in a what in a mountain array, right? We will write it. And of 5 minutes, the break has started. After the break, we will try some new problems. Like maybe they will not be purely based on binary search, okay, but they will be like good problems, okay. Like why I'm doing this because in the binary search, if I show you, like for the next few lectures, there are no new problems, or maybe we have to like take some new problems from the like by the help of AI, like take some new list of problems, not try to solve it by using AI. Okay, like you can see here, after this problem, I was supposed to do this today, but we will not take that. We will take that maybe tomorrow. And after this problem, there are no problems like on LeetCode. Like these are some different type of problems that are present on Geek for Geek platform. Okay, so yeah, we can do that. But after it, there are some lectures in which there are not so much problems, or which we can check for other variants of it. Yeah, there will be some random problems also, like not random, I will say, because we already have some good problems in the list, like good number of problems. Okay, like the number of problems that we have to solve are not less. Like if I check in this stream solve, then it's around 14, 15, right? And to solve, yeah, there are some questions in this also, but this is something different. Okay, let me see if this, what is this? Okay, we also have to finish the bread and tea, man. Binary search bit manipulation to pointers array. Given an array integer of ones and plus one integers, where each integer is in the range 1k, we have to find a duplicate number. Okay, I think we can do it using binary search, man. Like I'm feeling that we can compare it with the previous value or the next value of it, right? Like in that manner, it will be. But what will happen in this case, right? Like when we will compare 3 with the previous and the next, then it will be false. But 3 come 2 times, right, in the error. So you can see for that also how it will work. But we can try this also, man. Okay, we will see it. But today I was thinking to solve 3 new problems, like 2 problems. Sorry, the third one was a little, yeah. So according to the if we get time in the stream, the first one I was thinking about is bigger short second because it is pending from very long time, and after that I was thinking to solve that problem that was given to us on the did that when we were asking for bots to save people, and after that, new problems like assign cookies yeah, and other problems, we found that brother, give me those problem lists that you were um, talking about when we were solving. When you're solving what? When you're solving those assigned cookies or clear problems, and also give me. Okay, no. Just we will keep it here because in this we have talked about like this place problem, right? There have I think no binary search problem in this. Minimum number of arrows to bust balloons, right? Candy. Ooh. We will see that. And the second problem I was talking about is minimum arrows to bust balloons. Okay, balloons, right? Okay. Take these three also and also tell me like I recently started the binary search and have done problems like the binary search and search in rotated sorted array and peak index in mountain array, right? Peak index in mountain array. Do you want to suggest like same family or a different variant in binary search? Maybe duplicate number will be present in this, right? They are the next ones that keep building. Okay, binary search. If find first and last position of element in sorted array. Binary search for two boundaries, left mode and right modes. Teaches you how you tweak mid conditions. Find a minimum similar to rotated search, but now you're finding the pivot minimum. Builds intuition for handling rotations. Search insert position. Simple but useful variant. Teaches you how to return insertion index when element not found. Find peak element. Similar to mountain array but generalized. Binary search for local peak. Yeah. Find peak element. Let's see. I will check for this, and after that I will try like finish the lunch, right? Find the peak element, right? Find peak element. Find peak element second is also present here. Mhm. Okay, we can do that using binary search. Just what we did in the array visit, I think it will be somewhat similar to that, right? Like we can check for this condition. If this is true at any point, we will return mate. I think that's just the case. Okay, binary search, man. But why it's given in medium, right? Okay, I think I should take a screenshot of it, right? So no. Find a peak element. Let's see this also. Maybe there will be some. Okay, it's a great problem, man. 0, 1, 2, 3, 4, 5, 6, 7. Okay, it's a matrix. We will see that when we will on like grids or something, right? Okay, okay. Find the peaks. Empty. Okay. 1 and 3. If this is the case, then maybe in this problem, peaks will be counted as like, like there can be peaks which will be more than the previous and next value of it, and here it is also more than the previous and next value of it, that we have written this. Mountain 0 and Mountain 4 cannot be a peak because they are first and last elements of the array. Yeah, right. This can't be not the peak. Peak may be in just between these, right? So Mountain 2 also cannot be a peak because it is not strictly greater than Mountain 3 and Mountain 1. Okay, here. But Mountain 1 and Mountain 3 are strictly greater than their neighboring elements. Okay, man. Here also I think binary search will be used. No? What about finding kind of this map? Finding the peaks. Okay. Okay. Finding peak element. Finding a peak element second, but it's to the matrix, right? Generalized array may have multiple peaks. You just need to return any one peak index. Okay. Find peak element. Have I added this to where it's gone, man? Okay, it got added in this list. First, I will put it in the second list. Find peak element. Okay, find peak element. Second, we will not do that. Uh, find the peaks. Peaks. Maximum number in Bytonic array, similar to Mount Taylor array. Array increases then decreases. Find the maximum elements. Same binary search logic as mountain peak. What about finding the peaks? You're talking about finding peaks with binary search. That's a classic problem. Okay, man. We see Okay, so I have added find peak element, right? Find peak element, part one only, and also find the peak, find the peak problem also in the new list, right? Maximum number in Bitonic array. Maximum number in Bitonic, monotonic, bitonic, tritonic, compatibles. Uh, it's not string, man. Okay. I think we should keep it like here just for now. After that, we will have solved maybe these problems. Then I think we can maximum 69 number. What's the 6969 9969. Output is this. Okay, we have to keep changing the digits until it's the maximum number, right? Mm-hmm. 9669 9966. Why instead of that it did 9969? Okay, yeah, 9969 will be right. Okay, that till the break ends. You are going to see the problem that I've solved right revisited. I think we should close all these tabs. We just check for this in the find peak element is there, but what about find the peaks? Screen solve. We will close this. Text is open. Maximum sustainable limit. And okay. Just you all see the problem till the break ends. I will be back. I was thinking about this, that why the lighting is a little bit low. And that was because of I forgot to turn on the light. Hmm. So I think we should now just start the new problem of today. That will be, let me see how much time. Okay, it's already been 39 minutes, 40 minutes. The first problem that we will take is Wiggle sort. Okay, first we will try to do that, or maybe first we should try a problem in which binary search will be used, right? So it will be again reinforcing our mind. So for that, I think first we should maybe this is a medium level problem. Maybe we can do this, find the peaks. But I think in this, like if we even return the error, but maybe there will be another array for this, right? Like we can push back the value of that index in the array, right? Or maybe in that index only, right? So for that, we will first create two variables. Int start is equals to 0. And there is something also, okay, mountain 0 can't, because they are the first and the last. Okay, so first and the last will be excluded. So we will start with the first and end with the ending, like end with mountain size minus 1. Okay, the name is very big. Size minus 1, right? Like the second last index, right? While start is less than or maybe equals to end, right? Then in that case, we will, okay, before it, I want to create a vector, like empty vector, and we will name it as result. Okay, I think this will be a good name. And to start this, we will just check. Okay, first we will get the middle value, like middle will be equals to middle start plus end minus start and divided by 2. And after that, okay, so the mid has been calculated now. And just, I was just seeing that why the stream is a little bit buffering. This is this. Okay, this is done. And now we will use if condition if nums mid minus 1. Okay, okay. The condition will be somewhat similar to these that we have used for that problem. You know that we revisited was first peak index and mountain array, right? Okay, let's see. Search. Well, there are three search open now. Okay. If this is less than nums mid and nums mid is more than nums mid plus 1, right? Then in that case, we will push back that value. Result dot push back mid, right? Just the mid index. Mm, mm, mm. Because we have to return the index of that. And else if, but I think there will be a what different condition we used. Mm, it will not be nums, right? I will have to name it nums now. Hmm. instead of mountain. Already used nums so many in some places. Okay, nums mid, and here will be nums mid, right? Yeah. Now if this is true, then we will search it in the left side of the array and is equals to mid minus one, right? And else if maybe that will be bigger, then in that case nums mid plus one is more than nums mid, then we can try to find it in the right side, right? Like means start is equals to mid plus one. And in then when we will have added the values, okay, we also have to give it a size, right? But we are already pushing the value, so I think we don't need any size. And suppose if we not found that, we can return empty array. Okay, man, that's good. Don't know the stream is buffering a little bit. Even the network is good. Maybe it's just showing in my phone that is buffering, but I think in the reality it's not buffering. So I think in after traversing the whole array, right, we can return the ended here. After that, this function ended here. But how in this case we will return? Can we return inside this, and after that we will return? If we not found like there is no value present, then we can return simply this. But it will not work, right? Oh, it's passing one case, man. I think that was the case of empty. Oh, okay. Giving this in the output, but we needed this. What if I, instead of empty, we can, I think there will be a function where we can check if it's empty or not, right? What will happen in this case? Time limit exited. Really? Time limit exited? Uh, time limit exited. Let's see. Maybe if we do. Okay, let's see. I'm solving. What was the name? Find the peaks problem. Find the peaks problem. Till now, I wrote the code till this point. Is there some mistake or something? Just give me a hint or something. Don't give me the code or anything. Nice effort. You're thinking in the right direction with binary search, but here's the catch. The binary search approach usually helps us when you want to find one peak efficiently. In your code, you are trying to correct all the peaks into a vector, but the way you are moving start and end, Like binary search means you will skip over many indices without checking them. That's why your loop won't catch peak elements. Hint, think about whether you actually need binary search if the problem is asking for all peaks. Sometimes a linear can somewhat straightforward, man. Okay, I think binary search will not be used, right? So what you mean? Like should we not use for binary search? Exactly, that's the key point. Okay, so the binary search will not be used. If the find all peaks, then binary search is not the right tool. Binary search is designed to narrow down, okay, to one candidate, right? Uh, but here you want check every possible index to say if it's a peak. That means a simple linear scan. But here you want to check every possible index to, but that's a simple just loop through the array and check the neighbors. If the problem is find one peak like the class element, peak element problem, then binary search is perfect. Okay, man. Okay. What I will do, I will just copy this. Maybe we can use in this some different code. So we will just okay, we will just create a variable check named as check. Okay, check is equals to, let's see. And here we will use a for loop and go traverse the whole array. 0 I is less than nums dot size. Okay, it will happen. It will happen. And I plus plus, but it will start from the first index, right? Then we can compare it from the previous, and it will go till the last index of the array. That is very second last index, right? Then in this, we will check if, and here also be another vector, right? So vector integer result. Then after that we can add some condition that if nums check index, okay, sorry, if yeah, if it's more than nums check index minus one, right? If it's more than check index minus one, and add nums check is more than nums check plus one, right? Then in the result index, we can push back the index of num. Oh, sorry, check, right? So result in the result dot push back the value of the index of check, right? Just like this. Every time this will be true, it will add that. After traversing the loop, we can simply return result error. Even if it's empty, it will return the result error. Okay, there is something. Okay. Instead of this, we can start it from the first index, right? And maybe here it will be 0. Let's see what it's giving. Non-static function member must be called. Did you call it with no argument? Nums. What does this mean, man? Nums dots. Okay. Where is this thing is missing? Passing one test case in which it was empty, but in the second case it's failing. Output is one, but the second output is not this. It's giving one. Runtime, okay, it's giving out of what I can do is let's try to think about it. Okay, it can't be on the very first or very last index, right? We have done this. We'll check for that only. If nums check will start and yeah, check will be start from the second value and go to the second last, right? According to the loop, it will keep checking for it. Result output spec check. Then in the end, we are returning result vector. Then what's the problem? I think the problem is maybe in the condition, right? Check minus one. Check plus one. If true or oh man, I think I've mistakenly submitted. Okay. What about now? It will give yeah, bro. You are right, but there's some logic, still a logical slip, small logical slip. You wrote, but inside the loop, you are not using I at all. You are always checking check, which is fixed at one. That means okay, we can also use I, right? You will only use ever text index one again and again instead of carrying a whole. Yeah, because it's not increasing, right? So what if we instead of this just check for I? I right? I minus one here, and here it will be I. Here it will be I again, and I plus one, right? It was right, man, because it is not moving, right? Compile error. Okay, here it will be I, value of I. Now check. Oh man, what's that? Check with I in your condition. That way, the loop actually moves through the array and checks for it. Also, about the loop range, if you want to check neighbor safely, the loop range should be, yeah, we close it that I is minus one and okay. So the tokens just make sure loop bounds. But even after that, it's not giving the right value. Now, bro, this is almost correct now. You are just fixed the but just one detail left. The loop condition. That means the last index you will check is nums dot minus three, but the safe range for checking is from one up to num size minus two inclusive. Otherwise, you will check missing. So the loop should be. But I have done two, right? I have written two, man. And I why it's giving that, man? See clearly. I have used num dot size minus two. I see what you're pointing out. You did use, but notice carefully. One less than. Oh, less than or equals to, right? It will be less than or equals to. the second last index. That means you never actually search. Okay. Less than or equals to, right? Yeah, it will be less than or equals to. Because we also have to check for the second last index, but in that case, it will also exclude that. And it will run till the third last index. Okay, it's accepted. If I submit it, it will be submitted as usual. Was a good problem, I will say. Even if it's just that easy. Time complexity of the code of this will be, I think, big of n, right? Because we did use single for loops here. And space complexity will also be big of n because we did create another vector for it. Now I will check if I got you. Can you tell me how much code I was able to write? But so you almost wrote the entire solution by yourself. Let me, okay. So in terms, you 95% of the code was written by me. It's saying it just helped me 5%. Uh, help spot the off by one and earlier mistake of check instead of it. But there also another thing that I also remove extra variable by self. Yeah, that means you basically solve 98% of the problem independently. Okay, and don't know why it was a medium level problem, man. Why? Okay, it's a easy level problem. I was just was just a mistake, right? I thought it was a easy level problem. Sorry, medium, but it should be easy, right? Because it's very easy. So now I think first we should pick a problem in which binary search will be used, man. Because we also have to practice binary search. Find peak element or find the peaks. It's already done. Then why it's in the list, man? Let's remove binary search, right? Okay. In this binary search we will, so we can confidently write the code for binary search in this. Start is equals to end is equals to num start size minus minus one, and after that we will use a while condition while nums. Okay, it's peak element, right? So peak element can't be on the very last or very first, so it will start from the second value and go till the last value, second last value. Where it will be a while loop and we will use it while loop. Yeah, not nums. It's while start is less than or equals to end, right? Then inside this we will check if okay, not before that we will check calculate the mid is equals to what? Mid will be equals to okay. We also did have to mark that problem as solved. So find the peaks problem. Hmm, Find the peak. The name is good, man. We're on find peak element. We can put it here and just I'll close this. So input will be start plus and minus start divided by 2. After that, we will use a if condition. If nums mid minus 1 is less than nums mid and nums. Okay, there will be only one peak element, right? So we don't have to. We can just return the index of it. And this is more and then nums mid is more than nums mid plus 1. Then in that case, we will return mid index. Else if that. Okay. Oh, while writing this man, we can also just paste here, leave that. Why do we should paste that when we can write it by self mid minus 1 is more than nums mid. Then we have to start it like check it for in the mid minus 1, right? Like in the left side of the else nums mid plus 1 means the right side, right? If it's more than nums mid, then we can check it for it in the right side. Means start is equals to mid plus 1. There should be a spacing here also. And suppose we not found the mid, then we can simply return minus 1 if we not found the that index, right? I think we just wrote the same code, man. Saving compile error. Oh, let me just check for it. I think I should have to. I just opened my notes, DSA notes. Yeah, that's on. It felt like very similar to that, man. Just the name of the problem is changed. How is that possible? Can be possible. Peak indexing mountain error. But here we are finding the peak element. What if I submit it? Will it be accepted or will it be failed? Wrong answer. Expected was 0. Okay, so we can like put a case where like before the starting, right? If num size is only 1, if nums dot size is equals to 1, like 0. Oh, 1, right? Like there will be only one element present in that. Then we will just return n, right? Not n. Mm, nums. Maybe this will be true, right? Here it will be nums dot size, not this. Output is -1. It's giving z. Expected was 0, but that in that case it should be one value present in this. So okay, it was not almost similar to that, right? Let's see. Non-viable. What? Non-viable conversion from value of type vector int to function return type int. Type -1. But it's a vector. Okay. Let's see. What about this now? This is a new problem. Find peak element. Just guess now you're solving find one. But let me search. You're handling logic correctly. If this is this, that's exactly the standard. Small issues. Return statement type. This one compile you should return an index, not the whole vector. Where man? Okay. Can here it was given. Okay, we can return zero. Yeah, we can return zero, right? Just the index as zero. Boundary handling. Start this. That means you're skipping index zero. But why I want that and the last index num size -1. Okay, it will be -1, right? We just did a mistake, but it will be then. But peaks can exist. Yeah, but peaks can exist at the edges too. But how then we will check for the value, man? Index zero and index n-1. Saying edge cases can be also index n-1. Yeah, it will be two. This version is very close. You got the bunny logic right, but let me point out the very last few details we you need to polish. Correct binary search. Okay, we are proper peak condition check. Okay, early return when a peak is found. Yeah, special case for this issues left as peak not handled. Yeah, we have to check. Your search engine start is this. That means you're skipping index zero and index nums +1, but peaks can exist at the edges also. You need to check edge cases separately. Return value. But a problem guarantees at least one peak exists. So instead of -1, you should return 0 or nums size -1 if the loop doesn't catch anything. Hint for fixing before the loop, check nums 0 if num 0 is more than nums 1. Okay. Before the loop, we have to check if nums 0 is then return view. But then run your bunny steps in the middle part for the middle part. Before the loop, if we use this like here we can write it here if nums 0 index value is more than nums 1, then that case we can return 0. But what's happening, man? What if I remove it? Will it work again after that? Oh man. Okay, let's see. Also check if what n minus 1 is more than n minus 2. Okay, last index is more than this. Okay, so why not just add it into a single? Or nums n minus 1, n minus 1. That code is looking very messy, right? If expected semicolon, where it will be here, right? If true, this return 0. No, nums n, right? Will not be nums n minus 1, n minus 2. Wait, man. Yeah, it will be nums n minus 2 here. This is very looking very. You have basically nailed the binary search approach. Just a couple of tweaks needed. Binary search logic is solid mid check move let special case for loop boundaries keep at check return. Right now you wrote this always return 0 even if it's the peak is at last index. Instead you should check return n minus 1. Oh yeah, right. Was right because it will be that index, right? I'll copy this just. At check return. Okay, we can simply remove minus 1 also and replace it with simply like return start or return end. After we, one of them will point to a peak. Draw an example. Okay, we can safely remove that, or maybe we can also just keep it like that. This is basically the final polished version. But you got the structure right. This solid. What's perfect? The last detail. But the problem statement carries with it's unnecessary. Instead, after the loop, we can separate them because one of them will be with point of peak. Most implementations just start at the end. What if I not change the code now? Like I want to keep return minus one. If technically the code will compile, but here's cache guarantees. Yeah. Okay, it's just redundant. Okay, okay. I think I can also return 0. Yes, it is right. Like people can interpret it wrong, right? Yeah. It's the 4-digit count. If you, it's mathematically guaranteed to be right. Okay. So we'll keep it at start. Fine. Fine, ma'am. Lead code, hidden test cases. Fine. La 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 la. You know, it didn't take that much time, right? It's only been around 1 hour 20 minutes, and we have done the second problem of today. Find peak element. And yeah, in this, what we did before binary search, we check for those values. If only one value is present in that, then in that case, we can return that index. Like if one value will be present in the array, and that means the very first index is 0, so we can return 0. If nums 0 is more than nums 1, then return 0. If nums n minus 1 is more than n minus 2, but why this? Like maybe it will do trigger, but what if the middle one is weak? Good. Let's. The reason we check the edge cases first is because peaks can exist at the boundaries too. Or that's certainly what. After checking the edge cases, the loop runs through the middle and find any peaks there. So if the peak is at the edge, caught by the edge checks. If the peak is in the middle, caught by the vanishing source. This step one, guard the edges. That's the middle. But like to, okay, take this example. 2 comma 1 comma 5 comma 1 comma 2 is a peak caught by that check. So 2 is also a peak caught by the binary search. So 4 is, so as peaks can have split it, but in the middle as well as the edges. That's why the algorithm does both. Edge handle binary search. In your example, the middle we found while the logic. So the combo of edge checks plus guarantees you never miss a peak, whether it's at the start, middle, or end. But what will we get in the end? Which index? Yeah. If the problem is asking for only one peak, not necessarily the highest one, the LeetCode problem statement says return the index of peak element, not the maximum peak. Okay. So returning index 0 is still here is correct. It's not asking for the maximum peak, right? It's asking for if peak elements is there, then okay. But why? Then why it's applied in binary search part? I was also thinking to check the time complexity of this. I think it will be login, not login, maybe login. Okay, it is login. I'm so okay. I'm sorry. I was thinking to solve other problems, but today I solved other ones. But yeah, we did solve a problem with using binary search, right? Okay. Boundaries are chosen exactly to avoid that. So the peak element can maybe at the boundaries also. That for that we use these conditions, right? This and this. Maybe it is on the very first index. If very first index is more than the index next to it, then it will be a peak index, considered peak index. And if very last index value is more than very last index minus one value means very last index compared with very last second index. If very last index is more than very second last index, then we'll return that index number, not the value of it. And here we just use binary search to check for the peak if it's present. And peak will be marked as peak will be the value which like nums mid, where nums mid will be more than the previous and also the next element, right? Just this. We just return start as this safe boundary. I think we, what if I remove that? Okay, leave. I think I can also remove the last return statement, right? Okay, okay. Dead code. Trust your logic. Okay, we can keep it like that. Okay, we did two problems very early, man. What I think now we can take another problem also because we have done this. So, the next problem that I was thinking to take, I think before that we should take a 5 minutes of break, right? Like the break today, the breaks are a little bit longer, but I think that's okay. In break, we also do find some things. Now I will ask it from maybe suggest me another problem. I did solve find the peaks and find peak element. Oh yeah, just wait. Let it be done. Then I forget to ask it like how much code like I was able to write, right? How much code do you think I was again able to write in this problem? In this, okay. Then I wrote the whole solution against self by self. What Copilot messed me on was fixed edge case. Okay, at check return, separating 0 and n minus 1, like the very first index and the last index. Instead of always running 0 for that. Okay, I'm separating that both. Because when it will be at 0 index, then we will return 0th index. And maybe it will be on n minus 1 means the last index. Then we have to return that index, not 0. Explaining why the last return minus 1 is can, okay. Clarifying why we check H separately to avoid out of bounds and to catch peaks at the end. Okay. Yeah, because we use different type of edge cases, right? Check edge cases. You okay? Say 95% of code was written by me, or structure, logic, conditions, loop, and handling. Right? Means okay. Copilot is saying that his contribution was around 5%. Small corrections, polishing, explaining why certain lines are needed or redundant. Let's see what it says. What it had said. Nice work, you already knocked out fine peak element and that means to burnish the playlist is doing solidly. Let's update the roadmap so you can clearly see where you stand at and what next. Delete pointer done this. Next is minimum number of arrows to burst balloons. Should we do that? And also this is a hard level problem, like it is marked as hard level. I think it should we take it to solve. But in search playlist. Find peak element second, peak 2D peak finding. Oh yeah, man. But in that there is grid used, right? And we don't know about that. Hmm. We will have to pick our problem. What about this? I've added this problem today also. Like before the stream, I added this. Can place flowers. We have a okay. Uh, topic senior array greedy. Not this. Peak element is done, right? Find peak element. I will remove it from string files to favorite list, right? Then it's maybe. What if we try to solve this lead code profile? Please show your lead code profile. Hello, man. Welcome to the stream. This is my LeetCode profile. Me, yeah, we can say that I'm just a student of, like, just my college has started. Uh, First sem will start in the month of August. Like I'm currently focusing on, if I tell you, I'm currently focusing on DSA as the core and web development as the secondary thing. What about you, man? Are you also in college? Year six. So where we were finding that problem, right? Can you please candy? Should we take a hard problem today? Array, this will be a greedy, right? Okay. Yeah, we take this. Let's see. I think it was also mentioned in the list, right? Yeah, candy is there. Candy. There are n children standing in a line. Let's see how much time is left. I think we can tackle that. Maybe let's try to do it. Okay, the roadmap is already cleared. If we not be able to do that, and time gets stressed, we can end the string also because now the roadmap has completed, and there is no just any fixed rule, right? That we should solve the problem on a same day because the according to the roadmap, the problems has been completed. So there are n children standing in line. Okay, there are n number of children standing in line. Each child is assigned a rating value. Okay, like we can mark it as grid factor, right? Like he is a grid factor of 1, 0, 2. Value given in the integer array rating. We are given candies. We are giving candies to these children subjected to the following requirements. Okay, there are some requirements. Each child must have at least one candy. Okay, each child must have at least one candy. Okay, fine. Children with a high rating get more candies than their neighbors. We have to return the minimum number of candies we need. We will need to have to distribute okay, return the minimum number of candies. You need to have to distribute the candies to the children. Okay, 102. You can allocate to the first, second, and third child with two, one, and two candies. Why? When it was asking for only one, then why it was two, man? Why? Here it is one, two, and two. It was four. You can allocate to the first, second, and third with 1, 2, and 1 candies respectively. The third child gets 1 candy because it is satisfies the above two condition. Each child must have at least 1 candy. Children with a higher rating get more candies than its neighbor. Okay, that's also the case. Yeah. And this maybe there will be a or condition where maybe its rating is more than this, or if this rating is more, this index rating is more than this, right? Like there will be a or condition. If that's true, then the rating we will increase count of candy by 2. So first, I think there should be a candy counter, right? Int candy is equals to 0, right? We will check for it, and I think there will be a for loop used in this for integer I 0, I plus sorry I is less than rating dot size. It will go till the last index and ratings plus plus. No, I plus plus. Sorry, we are mixing the names. Then in this, we have to return the number of candies, right? We gave to the children. Okay, and before this, I think we should also sort the array. Sort constraints. This. Okay, let's ask it from. Why not ask it from this? I am on a candy problem. LeetCode. Can you explain me that problem? Like I have understood it and now just created candy counter and using a for loop. Before that, sorted the array already. Nice. You're on the candy turn. Let me explain it. You have n children. Each children has rating. You must give candies to each child such that every child gets at least 1 candy. Children Children with high rating than neighbors get more candies than those neighbors. Go minimize the total candies distributed. Key insight is not just about sorting ratings. The child are in line, so the relative order matters. Okay, we can't change the relative order. So yeah, we need to respect the original order. Initialize give vector candies left to right pass. What? Vector in candies. Okay, there should be another vector. Give everyone 1 candy. Left to right pass. If more than then candy I is equals to okay. This ensures increasing ratings get okay. And n is equals to what? N is equals to the number of elements in the number of childs, right? In the rating. Okay. Just the ratings. According to this, if we do int candies, no. Int vector candies. We are creating a vector, right? Candies. Sorry, vector. Yes. Vector int candies. And it's initialized with n and all the values inside this is this, and n is equals to nums, sorry, ratings dot with size, right? Then after that, this loop will run. Then we will check if we don't need this, right? If rating index is less than rating index minus more than, left to right pass, but right to left. If rating I is more than rating I plus 1, then the loop should be I plus 1. Okay, it is checking for I plus 1. So I think it should go till the, it's like not the last, right? Less than, it will go should till the this index, excluding the very last index, right? So that we will be safe. And it's not checking for I minus 1, right? Okay, it's checking for I minus 1 also. So, okay, we can start from the first. Then we can check if, and every time I think plus plus is also happening, right? Candies, sum up all candies. You have rated candies vector and also initialize it with rating vector size, right? And all the value inside that is 1. So yes, ma'am, exactly. In the standard reduced solution, we do this. Every child starts with 1 candy, okay? Because of the rule, each child must get at least 1. Okay. This vector is separate from the ratings vector. It's just another counter to track how many candies each child currently has left. This is this if ratings index is more than rating I minus 1, then what we have to do, candies something, right? Candies index is equals to candies, eh? Candies index minus 1 plus 1. Candies index, okay, is equals to candies index minus 1 plus 1. Okay. And in this case, if it's more than the previous next value, right? This ensures high rating than neighbor more candies. Okay. Yeah, yeah. But how the candies like not pointer is increasing, and also how we are adding plus 1 to candies or plus 2. Okay, let me show you exactly how the candies counter increases and why it adds plus 1 sometimes. Yeah, candies was the step to left right pass. We check if the current child has high rating than the left neighbor. If yes, we give one more candy than the left neighbor. Example, at I is equals to 2. Yeah, ratings is equals to 2. Rating 1 is 0. So candies 2 is equals to what? 112. Okay. So at I is equals to 2. 0, 1, 2. Rating 2 is equals to 2 and more than rating 1 is 0. So candies 2 is equals to candies 1. Index plus 1 is equals to 1 plus 1 is equals to 2. But it's already 2, man. Candies now 1 plus, but how it's been happening? 1 plus 1 is equals to 2. Candies second index. How, man? This will be the second index. Oh man, you said Candy's Candy's second index is more than second minus one, right? Then the counter of two should be increased, right? If a child rating is higher than the left neighbor, then that child must get one more candy. The left neighbor, that's why we do. If a child rating is higher than left neighbor, then that child must get one more candy than the left neighbor. That's why we do. Example, starting this. Okay, starting the candies were this one, 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 two. Okay, at I is equals to two, rating is this, rating one. Candies become two. Okay, one, one, two. Oh, okay, yeah, just working as the thing as how we wanted it to work, right? So it's fine. Second condition was just a different one, that is if the rating index is more than rating index plus one, then in that case candies index is equals to candies I plus one, right? Finally, sum of the candies factor to get the total minimum. And for the sum, I think we can use a for loop or integer I is equals to 0. Right? I is less than candies dot size or I plus plus. Every time we check, sum is equals to candies. No, candies sum, right? Candies sum, int candies sum, right? Integer candies sum. We can name it as candy sum. Yeah, is equals to mm, not ratings man, it is yeah candies I index, right? Then in the end we will return candy sum. Is the problem that simple? That no, no, really, no man. It will be integer n, right? Here it will be what's the semicolon. Let's just fix this a little. Compile error. Rating. Okay, it's ratings. So instead of that, we can okay. I think it should be ratings, right? Because there are different ratings. Rating. You traverse the whole area. This. But I think something is missing even after this, right? Candies in the expected what? Oh, here also. How did we? Powder too. Oh man, how many errors? Undeclared identifier? Where man? And candy some. Okay, if this is the thing, then we can first it was 0. Here it was equals to this. Oh, plus equals to right. Oh, hey, it's passing the space. Where output is 4 expected was 4, but here expected was 5 and the output is giving 3. Uh, maybe there's something, according to me, maybe there's something wrong in this, or maybe there's something missing here. About now, I tried to write it a little. And yeah, we are doing plus 1 so that it will be more than the neighbor, right? Candice index like the current index will be more, then it will be compared with this. If it will be more, then we will add 1 plus 1 candies to that children. Nice attempt. You got the skeleton in place, but let me point out what's happening in your code and why it's not solving. Yet solving. Right neighbor check is wrong. This overrides candies without considering what was set in the left pass. You need to max to avoid losing values. Max of candies I, comma candies I plus 1 plus 1. Only one pass. The program requires two passes, left, right to right, left. Correct structure is giving this. The problem requires two passes. Yeah. Okay, I think we should need, according to this state, two. It's different for loops, right? Separate for loops. So that maybe in the first the values will be increased in a different way. After that, we will again check for it. So you need the initialization and idea of comparing neighbors. Just split it into two passes and you use max in the right to the left part. That's standard. Where it's used max. Okay, here it is using max. Candies, comma candies I plus one. Why we did split and using max? Why even we need that, right? When we split into two passes and why we use max in the candy problem? The rule is if a child has a higher rating than the left neighbor, if a child has a higher rating than the right neighbor, they must also get more candies, means plus one candies, okay? Because it's not fixed, so we can fix it in like plus one candies. One single pass can guarantee only one direction. Left right pass ensures the left condition is satisfied. Right left pass ensures the right. Without splitting, you miss the cases where a child is bigger than the right neighbor, but not the left, or vice versa. No? Okay. Yeah, because in this we are just checking it for with the one neighbor, right? And yeah, even we can't use or here, but in that case, there will be one condition will be satisfied at that point, and even and not because maybe when we use and maybe it will be bigger than more than right or not left or right or left or not right. Okay, without splitting units. Yeah, where child is bigger than the right neighbor but not the left or vice versa. We miss those cases. Yeah, because we have to check for both cases, right? By max, we do need the second pass right left. We might overwrite values set in the first pass, but we don't want to lose the candies already given. So we take maximum. If the larger of two values, candies already set versus what needed for the right neighbor condition. The way both right and left conditions are satisfied. Example this. Initialize this with one left pass. 3 is more than 1. Candies is okay. Candice this become what 2 right pass 3 is more than 2 Candice 1 max 2 plus 1 is equals to total 4. If we don't use max the condition right pass could override Candice 1 back to 2 or incorrectly with max we preserve that the higher value. Summary split passes because each direction has its own rule and we are using max to avoid losing values already set and ensure both are satisfied. It's updated then after that it's checking the max of it, okay, in the left, right to left. Maybe so I got it like in the max in the right to left. Max is for maximum value in both left or right. But can't it be like it is more than both neighbor? Or we just need to check for one no no we will need to check for it. Maybe first it will be updated, then it will be, then we will have to also check for the mm, different side neighbor, right? Maybe the different side neighbor is less than that again, right? About the max. Left to right already gives some candies. Which side was bigger than the left? Right to left no checks if. Hello man, welcome to the stream. Hello. Right to left no checks if the child bigger is if the child is bigger than the right neighbor, right? Like it already checked for left. I was thinking about this. And after that, maybe it's more bigger than the right neighbor, right? After that. So we don't want to override the left result. So we keep it whichever is larger. Oh, okay. So just Max of candies index, right? And candidates index plus one. Bro, why use Copilot instead of ChatGPT? Any reason or benefits? No, I felt also felt that this is also good. This is also good, you know. I use ChatGPT in my mobile phone all day. Just it was already installed, pre-installed, so I started using it, and after that I found okay, it is good. It's not that bad, I think. Mm, well, it's running backwards. I listen. Okay, okay. Yeah, we can also write it like and it will be n minus one. So today I watch your oldest streams. Bro, your spoken English is improving significantly. Significantly. Huge improvement. Oh, really? Oh man, the mic was down, facing down. What about you? Have you tried speaking? Have you created any video that we can see? Overflow. Oh yeah. It will go to not n minus one, it will go to I is less than, not less than, more than or equals to zero. Yes, I tried, but it's too difficult to explain something in other languages. What language you tried for explaining? Like, it was English, right? Yes, and sometimes I was stopped at uh, but you know you can also use Hindi a little bit in between, like just as a beginner, you can do that also. Maybe just for the first few days. After that, you should try to fully like add English. Or it's also fine, man. If you get stuck in between, you just try to like utter some words out of your mouth. Like when you keep uttering some words out of your mouth, then the right word will come. Uh, you know, because right now you have heard like so many things in English, like so many different words for like multiple words, and they mean the same. Okay, but they are used in different sentences. But when you try speaking that, and when you get stuck, and even after that you try it, then at some point you you click the right word in the mind, in your mind, and after that, you utter that word from your mouth. I think it will come with time. It was also happening with me. So I started showing like, okay, I'm thinking and like this fillers words. Mm, or like you can also try if you are like you are blank, then you can just take a pause also, like just think about it, like what should be used in that place. Mm. But at least you tried. I think that was a good thing. You started taking action. Mm. So for how much time like you did practice it? Like was it 10 minutes or was it more than that? Long answer. It's now coming near to 4. It's passing second. Earlier it was 3, right? Mm. Condition plus equals to C. Today I recorded at least 20 videos or maybe more than that, but I deleted those videos. It would have taken very much time, right? Like so much time, 20 videos. Hmm. I think those videos were short videos, right? Like you tried it for like 2 to 5 minutes. Hmm. Yes, whole day I spent on making videos. But I think then after that you got to know the reality, right? And but it also feels like okay, we can improve if we try to just try like practice it every day. Yeah. Or maybe like just start thinking in that language. That's also helpful. If even if you not want to, maybe you're not using camera, even after that, maybe you solved a problem, then you can like do a dry run of it in your mind using English. Or maybe you are roaming around on your rooftop alone, then in the morning time or at a time where there is no one near you, then you can just do a dry run of the problem or just talk with yourself using English. Why today you do POT? No man, no, no, no. But I find no words in my mind for thinking. It will come. It will be added. The new words will come in your mind. Just things need a reset. Problem of the day. Yeah, I know about that, but I am following a roadmap, brother. I'm not that level of professional or something. I'm just a student who comes on a daily basis and solve DSA problems. And also I'm following a course. And first of all, welcome to the stream, man. What course, buddy? Yeah, this course. Like this is just a single course. I'm also taking some problems by myself, like creating a list every day, and I add every day I add new problems. Right now, I'm solving this problem. Name is Candy. We have to give child candy to childrens. Mm. Bro, have you watched my video? What video? Have you shared any video on Discord? If you're following any course, I will recommend. Oh yeah, I know about that guy. I think I've also subscribed him. Glasses man. Oh, you're talking about him. I don't know him. Yeah, see, I will check out it after the stream. So but I'm doing DSA in C++. At that too easy. What's your opinion about Striver? Uh, left to right, right to left, left to right, mm, right to left. Yep, this playlist is in C++. Not to worry. Okay, if that's the case, then maybe at some point I will be stuck at any concept or any problem. Then I will try to watch his lecture, maybe on that particular problem or topic. Maybe I get stuck at this problem and I want to see from him. And I think I can same also. A ratings index. Oh, where you have shared that video, man? Are you going to share it on Discord? But two small issues, left to right loop range. You wrote left to right. Why? This stops at, oh yeah, I is less than already is less than n. We are already excluding the last index. It's fine, but depends on if pass fixed one. Ooh, Speed's only 14%. Why? Subscription. This is the word most optimized solution for this. Okay. Time taken big often. Hmm. So I think in this problem, what's happening? So yeah, what are doing in this. First, this was just variable for like checking. We will initialize with the number of elements present. Then after that, we created an empty vector and initialized all the values with one. And all the values with one means all the children have already been assigned at least one candy. Okay. Then after that, we are checking for right to left. Like if sorry, left to right. Hmm, if ratings of ith index, yeah, this index is more than this index, okay, previous index, then in that case, we will add plus one candy to give plus one candy to that children. And every time this is happening, we will give that one. Oh, let me show you a trial by using this. Give me the trial in which both loops will be used in a good way and simple way. Let's do a simple brackets where both loops. Okay, taking ratings as this example. Okay, first we initialize the candies with this, and yeah, here we are comparing ratings index. Okay, according to that, we will first we were here. We check. Okay, it's more than the left side, right? Yeah, left side neighbor. Then in the candies index, that is yeah first index, right? Sorry, second value. We will increase that one from 1 to 2. So in that case, 102. Now take 102 as example. Again, give 102. Okay, now this is this and this was a candies. First left to right pass from left to right. Yeah. No candies change. 1. Ratings 1, index is 0. Oh yeah, 102. Fine. No candies states as 111. I is equals to Z2. Ratings 1. Yes, candies 2 is this. So candies 2 increase. Right. Why? Because when we check for this, comparing it with the left, like comparing 2, oh, it's showing there, man. Comparing 2 with 0, like the left, then it was more. So we give one more candy to that children and number of candies to that children become one more. Okay, left pass done. Now we are in the right pass, step 3. Okay. We are looping from I is equals to n minus 2 to down to 0. Okay, I at the first iteration, first index is 0. Rating 1 is 0. Okay. Means the second value is 0. In the ratings vector, is it more than the next value of it? Right? Not. So can we state like this? But if we check for I is equals to 0, rating 0 index, means first index. Is it more than rating 0? Yes. Candy 0 is equals to max of candy 0 and this. So max candy is equals to, like, become this. Candy is equals to 2 plus 2, 1, 2. Okay. Right was done. Because it was already 1 here. So when we compared, check for it, we got that it is more than 0. Right. So we added one more here. Like he got one more candy. Because of that, in the end, the distribution of candies are like this, right? First one got 2, then second one only 1, and third one got 2 again. Sum is equals to 5. Okay. This is how the dry run is working. Okay, we can remember that also 102. Again, we will do that. Every child starts with 1 candy. Okay, every child initially has 1 candy. And now here we are comparing, okay, loop from I is equals to 1 to n minus 1. Means we are going from the second index, second value to the second last value, right? Hmm. Not second last, till the mm, mm, to the last, right? Yes, it means the last index of the array. N minus 1 is that's the last. It goes till n minus 1, the last index. Okay, it goes till a last index. So this is going till the last, not the last, right? N minus 1 will be, if it was n, then it was going to 1 to, it goes till n minus 1. That way, okay, because it's starting from the 1th, right? And when we write this, it starts from the second last child and goes back to 0. Okay, so that we can compare the current value with the next value. That is the right value, right? Okay, so it's going till the last index, and here it's going till the second last. Ratings 1 index value 0. When we compare it with ratings, yeah, 0th index, then it was 1. So no, candy stays like this. When we compare the next value, like ratings second index value to with ratings, sorry, ratings index value like third value with the second value. So third value is more than second value. Then candy, the number of candies that child will get will increase by 1. Okay. Left pass is done. We are out of the left loop. Then after that we will check right pass. Okay. Because maybe some child is left in the left pass. Maybe it's not more than the left. Yeah, it's not more than the left side, but maybe it is more than the right side. Okay, then we will check for it. So here we are looping from the second last index to the very first index, right? when I is on the first iteration, ratings first index was what, 0, right? No, second value was 0, and second value of 0 is not more than a right index, that was the third value which was 2 where, but so that in that case Candy's value state like this 1, but when we check for the 0th index, that is 1, that value is 1 means the very first index, and compare it with the second value, that value is 0, in that case it is more than the value 0, right? 1 is more than 0, so Candy's 0 index will be what? After that we will check, it will be equals to max of the candies at 0, comma candies at 1 plus 1 is equals to max. So 1 comma 1 plus 1 is equals to 2. So it will be 2. I will ask it for max. Why even we using max after that? Like, isn't we eventually checking for right? Still use max in the right to left. When we do left to right, we already give candies to children for bigger than the left neighbor. Now on the right pass, we check against the right neighbor. But here's the catch: child might already have a higher candy count from left pass. If we blindly override it with, we could reduce their candies and break the left condition. Oh, yeah. Then maybe that he will give, he will get more candies, like more than what it should be more, right? Mm, Here it's example given. Example is 1, 2, 3. In it, just left pass 2 is more than 1. So 2 and 1, 2, 3. 3 is more than 2. Now imagine if we don't take max and had case like 2, 3, 2. Left pass 1 to 1, then 1 to 3. Right pass. So that's the value already set in left pass. Like I got you when you um, split the array at that point. But what, why not? Just tell me in clear way. Okay, right pass. This ensures that if problem without max, if 1, 3, 2, this left pass 3 is more than 1, then it becomes 2. Right pass. The 2 is not more than 3. Then it will be like this. Then in the right pass, 3 is more than 2. Candies 1 is equals to max of 2 that is already present, comma 1 plus 1 2. Oh, 2. In the right pass, we compare 2 comma 1 plus 1. Means candies I plus 1 plus 1. Right neighbor, okay, it's already more than right neighbor. Okay, candies I plus 1 plus 1. It's already more than right neighbor. Max is, if left pass have already given more, then we not have to reduce that. Example, this again, this example. 3 is more than 2. Yes, candies 1 index 3 will be like here. It's 2. Already it has been 2. Mm, max of 2 candy 2 plus 1 plus 2 plus 1 is equals to max of, oh, means it also saves us not saves, keeps us safe from maybe a child if we not use math, then maybe we will get more than the required money. Oh, can reduce that. Oh yeah, because we are comparing max, maybe because in the right pass, maybe it will give that, assign that value to him. That value will be, maybe it will be less, right? I was thinking about that like when I, started asking from it, and I was thinking about it from the very early, and then I should have asked it before. And if according to the right pass, if it's giving more candies, then we can pass the right. It prevents a child from getting less than required, breaking rules. It also prevents a child from getting more than required, and because we only keep the largest of two values, two valid values. Hmm. I was thinking about it from just when you gave a code for maths. Now tell me how much code I was able to write by myself. Like I was able to understand what we you have to do and also knew the condition of the loop with what will happen in the inside the if conditions. We did really well by ourselves. What I nailed correctly this name loop conditions updating candies. We wrote the logic side if properly summation. We added up the candies at the end. This shows you clearly it's in the core greedy idea. And yeah, this is also a greedy problem, okay? Like from the past few days, I'm into greedy algorithm problems. Like I'm loving these type of problems. What need refinement, loop ranges. Yeah, let's skip the last slide. Okay. Last telling what refinement it did. Two pass requirement. You tried to handle both directions in one loop, but the problem really needs two separate passes. Use of max, you didn't add it first, but later installed why it's needed to protect the values from being overwritten. Overall, you basically wrote 70 to 80%. Well, we knew the initialization, neighbor checks, and summation. It just helped me on splitting into two passes, right and left separately, and using max to combine both conditions safely and get the required more value, like the correct amount of more required value. That's a solid effort. It means you're not just copying code, you're actually understanding the grid logic and building. Yeah, and there was another problem that I was thinking about, like I'll not solve it today, but it's already in the list in which there will be greedy algorithm used, and its name is patching array. This is also a good problem, like I'm trying to understand it from ChatGPT, not in the live. We will solve it someday. Okay, this problem is solved. Now I think I should maybe summarize the stream or end it. So what we did in today's stream is just summarize it. Okay, and today we also gone against our like roadmap again and solved another problem, like one more problem that from that. Like it was supposed to be solved only two problems today, but we did one plus one also. And yeah, today we solved our first hard like problem. Okay. It was marked as hard, but I think that's not that much hard, right? So the first problem, like first I revisited a problem that name was peak index in a mountain array, and time complexity was equals to log n because time binary search is used in that. And after that, I solved the new problem of today. That's name was find the peak, and its time complexity was equals to big of n because we reduced for loop for that, and binary search was not allowed in that. After that, we solved. Yeah, it was a easy error problem. Okay, the first problem that we solved today was as easy level problem. Name was find the peaks. After that, the second problem that I did was find peak element. And in that we did use binary search, but before that we also like needed some checks, and after that checks the time complexity in the code of this was equals to, yeah, it was equals to log n, right? Let me just check it. Should be log n. Yeah, it's log n. Yeah, it was log n. And after that I solved the third new problem of today going against the roadmap. Like it was supposed to be only solve two problems today, but I solved this also because we were having some like good amount of time for ending the stream. So we solved this problem and time complexity was equals to log big of n. Okay, because we did use for loops here to write the code of it. So in total, if I summarize it again, we revisited one problem and solved three new problems. And first we revisited this problem, peak index in mountain area. Time complexity was log n because of binary search. After that, I solved the first new problem of today, find the peaks. It was an easy level problem and time complexity was equals to log n. After that, I solved a second new problem of today and it was a medium level problem. Okay, name was find peak element. Time complexity of the code in that was log n because we did use binary search in that with some predefined conditions in which we directly return the answer, but time complexity was equals to big of log n. Okay. After that, I solved the third new problem of today going against the roadmap. Its name was Candy, and it was a hard level problem, and its time complexity was equals to big of n because we did use for loop in that. I think in today we also like first we solved an easy level, then medium level, then after that an hard level problem. I think that was nice. So this was all for the today's stream. Just we did one revisit and solved three new problems. I think I've repeated it so many times. Let me just check it in the greedy. Oh, not in the greedy part. What if I check it in binary search? Search in bit. Okay, it's already done, man. Why I have not marked it? Search and rotated sorted array. We have already done it. I think I forget to mark it as solved. This needs to be solved. I think we can solve it yes tomorrow. Okay, this was all for today's stream. So I think hello. Okay, fine. So if you so for now you can like the stream, and if you feel that you learned something from the stream or maybe getting some good value, or like feeling that okay this guy is a good guy or is teaching something good, then you can consider subscribing to the channel only after that. I will now say that you should just directly go to the channel and just subscribe only after I say that okay you go and go subscribe to the channel. Not do You should not do that type of things. You should just subscribe to the channel when you feel okay this guy is good and he's teaching something or good or doing some good things. Okay, then you can consider subscribing, and when you will subscribe then maybe when I will be live again and maybe upload some videos, then upload new videos, then you will get notification in your home feed or notification section, and you can come again on the live and see me solving these questions or explaining what is happening in the questions, and we can also have interactions. But I will strongly recommend all of you to join the Discord server. There you can share your daily progress, like what are you doing on a daily basis, and also like I'm trying to create a community of good people. I will recommend to join the Discord server where people help each other grow together. Okay, and in the last, I will say please do give reviews in that comment section also, like what things should I improve, or what new things should I come up with, or should I change something in my explanation style, or should I change something in my approach, or do you want some like content on some topic, like a separate video for that, not maybe just not from DSA, like this is just live streams. And I was also thinking about to start the project series. It is getting delayed from a very long time, right? But yeah, today I also finished the DSA notes, which was pending as a backlog. I started it yesterday, but finished it today. In today's straight time, I finished it. I think this was all for today's stream. If you what you all have to do then, you all have to just wait. Mm, okay. So you all have to just till then keep learning and keep exploring and keep grinding.